back everyone. This is going to be kind of a two-part update on cx16os, kind of my operating system Unix like project for the targeting the Commander X16. The first video is going to be on some of the older stuff, I guess. Going to be on the assembler, or a little bit about the assembler I wrote, and also Scripture, which is sort of like a scripting programming language I sort of came up with for cx16os. So let's get right into it. Already into the commander here. I'll come back to this in the next part, but you can just think of this as changing a font. I mean, you could already start to do this. But yeah, let's take a look at it. So so the assembler, I mean, pretty standard syntax, I would say. So let's look at a code file. So yeah, I mean, just looking at this, actually, yes, I can. Am I? Oh yeah, yeah. But yeah, so just looking at the top first kind of part of this file, we have some definitions. So every directive starts with a period, which is similar to other assemblers, but unlike other assemblers, you can't use an equal sign for assignment. You have to use like the dot eq directive, which I think some other assemblers do. And then so you give it a name and then a value. It can either be decimal or hex. Either works, and then hex is preceded by a $, like in most 6502 assemblers. And this is only a 6502 assembler, despite the fact that cx16os does only run in a 65816. It's just easier to implement for a first project, and you can totally write programs only in 6502, so you're totally good. So I thought it was capable enough. But this is just basically the program touch. So it just creates a file and doesn't write to it. So if you just look at this, you can print the rest of it. Why don't we just? I don't know why it said the bus are modified. So I mean, just scrolling through this file, you can kind of see there is a basic kind of expression evaluator, so you can do like LDA pointer 0 plus 1. You don't have to define like pointer 0 high and pointer 0 low. So, which I think is pretty neat. You can also have constants that are like character, like W, that will translate to the the ASCII value for capital W. There's labels here. No local labels. You could hear the beep when you reach the end of the file. But yeah, we can just exit out of there. And yeah, let's just try assembling it. So I never really thought to get rid of any of the debug messages, so it actually just prints a bunch of info. I guess we could just, if we want to, we could see what it prints out, kind of go over it. So yeah, basically it just prints a bunch of data. And I mean, all of these are instructions. I think these are all instructions. So I mean, yeah, and then you can see the operand. You can see the addressing mode. So example, like 01 is immediate. 04 is absolute. So these are all kind of absolute loads. This is a absolute trying to 0b, like indirect, or sorry, relative. Relative for branch. Stuff like that. And then the next time it just prints out all the addresses as it goes through the file, and then it does it without a $, but not the most interesting. But after this runs, you'll get a.out, and a.out, if we run it, this really makes sense. Example.txt, you know, and if we, yeah, there's no content, so it won't display anything. But yeah, so that's pretty much it. So yeah, that's sort of how the assembler works. I'll delete this stuff now, and we can kind of move on to scriptor, which was sort of I don't want to say the focus, what I wanted to focus on, but I think a little more interesting. There are plenty of assemblers out there, so but one thing that's kind of funny, I forgot to mention this, but I do think it's kind of funny, is you can actually it will read from standard in if you if you just start typing. So you can do something like buff. Maybe buff isn't the right word, but 9009, which is print stir LDA 0 RTS buff. And if we run this, it prints hello world, which was sort of the program we wrote into standard in. So it's kind of funny, at least I think. But let's go on to scriptor. So scriptor, again, kind of a programming language. So there's two ways to run it. You can run it like run it and give it a test file. So we'll do table.sr, and this just prints like a kind of times table. Or you can run it in interactive mode, which is sort of like Python. You can do Python like this, PHP, a lot of languages, and then you can just exit with X, or you can actually also close standard in with Control D. But yeah, so this is interpreted, as you kind of could probably tell. But let's kind of dive into the syntax. So let's just Alright, so yeah, this file is not super big, but yeah, so variables are, so the first thing you probably want to know is how you declare a variable, and that's pretty simple. How you just use a $sign, give it a name, and then just give the value afterwards. No equal sign is necessary. So yeah, so we, in this program we define start to be 1, end to be 13, and factor to be 12. And you can do the same thing to assign one variable to another. So we're going to define, set I to start, and then the next actually thing. So this hash loop, or a hashtag loop, that's sort of a label, like in an assembler, sort of inspiration. But what it actually does is it basically declares a variable loop. It declares the variable like hash loop as equal to the line number. So when you go to the when we get to the goto kind of command, it goes to a line number. So you can use an intention with that to kind of do branching. So the next line is just m is equal to I times factor, and I think it's pretty cool that you can do expressions like this. It's actually kind of ripped from the assembler, but upgraded a little bit. I added multiplication to this one. And the next one is sort of the explanation point. Also works with a dash, but this runs a program. So it just basically compiles into a string and splits by spaces, and then runs the program. So echo I times factor equals m, and that's why we were printing those that's why it looked like that timetable there. And then after that we just increment I by 1, and so this question mark is a conditional. So if the value before the comma evaluates to something that's not 0, it will do whatever is after the comma. So in this case, if I minus 13 is not 0, meaning basically I is not equal to end, go to loop, and that's sort of why we have end be equal to 1 more than 12. So that it will print 12 times 12 equals 144, increment I, and then I will be equal to 13, making the condition not branch anymore. And that, you can see the percent sign, that is the goto sort of statement. It can be unconditional. Obviously, it'll cause a loop. But yeah, you can do that if you want. So that's one way to do it. Let's look at another program too. So there's kind of some other stuff you can do. Yeah, this doesn't even show the at kind of command. Let's do args, and we'll print this. So yeah, so the first thing this program does is this at symbol, which actually runs sort of either like a OS routine or sort of an internal args routine or scripter routine. Sorry. In this case, get argc, and the scripter actually kind of like strips out all the like scripter, like it doesn't see that. It only sees arguments to the program. So it'll see like get argc, and then what this does is it returns the count in the A register. It's an assembly routine. And how we get that to a scripter variable is just to use, like when you're declaring a variable, just to set it equal to .a, meaning like the A register. You can do .x, you can do .y, you can do .c for the entire accumulator, 16-bit. By default, if you just do .a, it'll be just the lower 8 bits. You can do .ax if it kind of returns in that kind of register pair. And now we set I to 0 is just as our kind of our loop variable. And then we go to the loop check. So the loop check just compares argc to I, and if we're at the end, if we're not at the end, rather, we'll branch to loop. And what this does is it will get arg with A equal to I. So what this will do is basically it'll go through this line with get arg. You can actually see my cursor. But so you'll go through this line right here, and we'll set A to I, the value in I, before calling this routine. And what getarg does is it returns a string in the AX register pair, which there are other routines that do this too. And what cx16os does is if routine returns and the value of AX is a pointer to somewhere like greater than 8,000, which is where programs live in cx16os, and the string is less than like 64 characters, which is like a limit of how big a string can be stored in scripter, just a limitation of the program. It will set this .stir value to equal to it. So now we echo args. There are spaces around the brackets because it was sort of a parsing issue initially. So we'll print args sub I and bracket colon, and then we use this hash value to tell scripter that it's a variable that we're printing that doesn't start with I. So in this case, we see here the I for that variable. The assembler knows it's the scripter knows it's a variable because of the dollar sign. But otherwise it wouldn't know that for .stir. That could just be a string. And then we increment I again, and then we have the same loop check, which keeps on going. So yeah, let's just run this. So scripter args does R, and we're going to provide it some args. Hello world, and let's do one in quotes so you can see it's like one argument. So yeah, so you can see hello world and then test space, which is one argument because it was quoted. Otherwise it would be two split on the space. So yeah, that's sort of some more code. What other files do I have in here? We have table, we have args, we have demo. Demo is kind of interesting. It's not I don't know. It's kind of interesting at least. So scripter, it just asks you to enter a file name. Let's do a.out because I believe this will just run xxd on whatever file you enter. So hello world. But what this is actually, it's a little more interesting when you don't actually enter a valid file name. I don't know. There we go. No, that's not what I meant to do. I meant to enter it there. So it says error unable to open file GGGG, and that's not actually like XXD printing that. That's actually the program. So if we'll just less it. More it. So yeah, so programs XXD, we print stir, enter a file name, and we use the Oh yeah, the kind of caret operator or greater than, which just reads a line of text from the user and saves it to file name as a string, and then it tries to open a file for reading. You know, and if it works, it will treat it as that file exists, and if it doesn't work, it'll it'll assume that file doesn't exist, and kind of error, and then go to the end of the file. So that's sort of how that works. Another example of branching, the caret operator, which is interesting. And all this stuff actually is the same. It kind of works exactly the same in the interactive mode. So yeah, the only difference really is you have X to exit descriptor. Let me clear. But one thing that's a little different is that if you want to do something like this, if we want to declare I to be 0, we'll call a loop, and we'll do, what you can do is you can backslash, and this will actually delay execution until the next time this line is encountered, but that was not entered. So if we enter like this, because if you were to just type this, it will execute it right away, but that's not what we want. In this case, we will have it execute right away because this will take the branch because I is not 10. So we'll do this. This should work. Did I miss something? Oh, that's not. Sorry. Oh. Okay, I think. Well, clearly it worked somewhat, but my printing is not. That's weird. I'm not sure why that is. Let me try that again. Loop. You can't overwrite these labels, so let's just. Oh, that's why. That's why I was not using the right. That would make sense. All right. So this should work. I was just not. I was just setting a variable called echo equal to I, and that was why that was not working. So let's try this again. So yeah, so this time you could see it doesn't actually print until you run the command, or you branch to it again, which I think is kind of interesting. And if you're typing these programs, is helpful. So your first iteration doesn't run when you're typing it in. And if you type something nonsense, it will not actually crash. Like if you if you run a program that's nonsense, it won't work. But this will. And you can kind of prompt, we can sort of prompt it to break like this. Like if we just, yeah, like this. Like obviously hello is not a valid, command, so this, won't work. And this kind of hash, thing is you can open streams this way. So it's sort of like providing dev.snetterin on on another, on a Unix machine. But it's sort of hard to parse the directories to this because you could do .dev. Yeah, I don't want to have to figure that out. It would be slow, so it's just easier to do this, basically. But that wasn't the main focus of this video. We're already kind of approaching a little bit on 20 minutes, but that was sort of the highlight of the first episode on ASM Inscriptor. Maybe not as interesting as some of the stuff I'm going to show in the second part, but wanted to thank you again, for bearing it with me. If you're interested in stuff, this is on GitHub. It'll be linked in the description for this video. It's on the cx16 forum if you just want to download it. Unfortunately, so there's actually someone actually was kind of hearing my ALs and did actually make a PR for the x16 emulator that allows you to run the web emulator with different options. Namely running it as a 65816. But the problem is that version of the emulator is not on. It's either I think it's just not. I think they're just waiting for R49 to update it, which makes sense. I think it's on R47, but it's not. The commit was after R48, so it wouldn't really matter. but they're waiting to change it, and at the moment you can't run it on the web emulator on the forum, which is too bad. And I did try to like compile it at home, or maybe put it on my website so people will try it, but that wasn't working either. It was having some weird issues, uh, but yeah, so yeah, there's a download on those two platforms. Obviously, you can just download the image. That's the easiest way to run it on the emulator. I wouldn't. I mean, I don't know if I've ever tried to tried to run it just like with HostFS. I mean, I think it would work. Um, Actually, I really have no clue. It might not work, but but it might. So you could do that, and then obviously the files. There's a zip. And then that you can kind of just copy to the root directory of your SD card. And on the GitHub, there is also an install guide if you're interested in that. So if you're any interested in putting on your SD card, I would look at that because it's sort of you just want to make sure you have all the right files because you don't just need os.prg. I mean, you need all the like bins, all the binaries. Not all of them, but like you're gonna want some of them. It does that in the real more, and it's not, or it's in less, and it's not quite as jarring in that version. So, but I want to keep that behavior. But we'll talk about that in the next video. Thanks everyone for watching this part. Appreciate it. I'll see you next part.